Okay, so for an example 6.2, for the three-phase system below, calculate the per unit values of all components in the system using 12 MVA as MVA base. So you need to use 12 MVA as kamu punya MVA base. And then for number 2 is you need to draw the per unit equivalent circuit. So for number 3, if three-phase balance fault occurs, maksudnya symmetrical fault, at bus number 3, calculate the fault current, which is ia punya current short circuit in terms of per unit and actual values, and the fault level of the ia punya actual value, which is SSC, and this one is ISC, this one is ISC SC per unit. And then for question number 4, fault sama juga ISC, SC, PU, SSC at bus number 2. For question number 5 at bus number 1. So looking at this diagram, I believe all of you should know on how to transform this diagram into per unit equivalent diagram. So let me just copy this diagram first. Okay, so if you draw your punya equivalent circuit, ya jadi, and then we have reactor, regenerator type, and then bus number 1 we have transformer, number 2 we have transmission line, and then bus number 3 we have a load. So this is XGPU, this is XTPU, and there's XTLPU. So G, since generator side voltage and the transformer voltage here is 11 kV, so VPU is equal to V actual divided dengan V base, you should get 1 PU. So for the generator side, since we use SB equal to 12 MVA, so this is also 12 MVA, so we can just use 0.25 PU. Then for this one, XTX, you punya MVA here is 6 MVA. So we need to change this transformer punya per unit using the SB new. So XT per U new equal to J0.5 kali dengan 12 MVA divided dengan 6 MVA equal to J1 PU. So we can put here J1 PU. And then for this one, first you need to calculate what is your punya ZB. So once kamu dapat your punya ZB, ZPU equal to Z divided dengan ZB. So ZB here should be equal to VB square divided dengan SP. So ZB equal to VB square divided dengan SB equal to voltage di sini is 66 kilovolt. So 66 kilovolt square divided dengan 12 MVA. Impedance base should be 363 ohm. So kamu punya ZPU equal to 0.5 plus J 1.5 divided dengan 363 equal to 0.001377 plus J 0.004132 ohm. So for question number 3 here, okay, so you already done converting all the values in terms of per unit. So the next question, for question number 3, what will happen? You want to calculate what is the fault current in terms of per unit and actual values. So maksudnya di sana, what happen kalau ada fault occurs arah bus number 3 here, ada fault. So kalau ada fault occur here, what happen to this load? This load will be ignored because current will go to here. So this is kamu punya ISC. Okay, so if you look at this diagram, how do you calculate ISC here? This diagram is a series single phase diagram. Okay, so if you look at this diagram, ISCPU equal to V divided dengan Z total. Correct? This is an Ohm's law because this one is already ignored because kamu ada short circuit current here. So ISCPU equal to V, which is VS divided dengan Z total. So since kamu punya VS is equal to 1, and then the Z total is XGPU plus XTPU plus dengan XTLPU. Okay, so you can calculate. So you can calculate 0.25 I plus dengan 1 I plus dengan 0.001377 plus dengan 0.004132 I. So kamu punya total impedance should be equal to 0.001377 plus J 1.254132 ohm, and then kamu punya ISCPU equal to 0.79736 angle minus 89.37. Okay, so this is the short circuit current in terms of per unit. The question suruh kamu cari the short circuit current in terms of per unit and its actual values. So how do you calculate the actual values of this one? So ISCPU equal to ISC divided dengan I base. So ISC equal to ISCPU kali dengan I base. So if you want to calculate ISC di sini, you need to know what is you punya I base. So I base di sini arah bus number 3, you can calculate by as you recall in kamu punya per unit calculation, SB equal to VB IB, sorry, SB equal to root 3 VB IB. Therefore, IB equal to SB divided dengan root 3 VB. Since kamu arah bus number 3, the voltage arah bus number 3 is 66 kilovolt. So 12 MVA divided dengan root 3 66 kV equal to 104.97 ampere. So ISC equal to this value kali dengan I base, which is 104.97. ISC equal to 83.7 ampere angle minus 89.37. So now kamu sudah calculate ia punya short circuit currents in term of per unit and also short circuit current in terms of actual value. So the next one is you want to calculate what is ia punya fault current, fault level. So if you recall back on what is the formula to calculate for fault level, so SSC equal to root 3 V line ISC. Okay, disuruh V line. So kalau kamu observe, kamu punya fault occur arah bus number 3. At bus number 3, what is ia punya voltage? V line di sini. V line equal to 66 kilovolt because you are following voltage yang dari transformer sini. Di sini 66 kilovolt. Here should be also 66 kilovolt. So SS. So the SSC equal to root 3 V line kali dengan ISC. So root 3 kali dengan 66 kilovolt kali dengan this current you should get 27,3452.75 VA. So this is the fault level at bus number 3. So apa yang kamu buat right now is only fault level occurring at bus number 3. So that is the question for question number 3. Fault occur at bus number 3. So for question number 4, what happened kalau kamu ada fault occur pada bus number 2. Bus number 2 here ada fault. What happened to this area? This area will be ignored. So kamu ada ISC di sini. Okay. So how do you calculate ISC here? You can calculate sama metodnya dengan yang tadi, but you just need to ensure you are using the right base voltage masa converting in terms of per unit, masa mencari ia punya anything lah, kalau mencari ISC atau ISC PU and also mencari ISC. Then for question number 5, suruhnya kamu cari fault occur pada bus number 1, ISC here. So ISC here, kalau kamu ada fault happen occur pada bus number 1, all this area will be ignored. Okay. So bear in mind that arah bus number 1, kamu punya base voltage and V line voltage is equal to 11 kilovolt. Only arah bus number 2 and bus number 3, the voltage is 66 kilovolt. So you need to bear in mind kalau masa kamu mencari ia punya actual value. So you can try the question number 4 and question number 3, question number 4 and question number 5 as kamu punya practice. If you have any problem, you can see me in school on how to solve the problem. So to further practice kamu punya analysis, you can try exercise problem 6.4. So this is the diagram. So I have list down di sini ia punya answer for the short circuit current and the fault level occur at bus number 3, bus number 2 and bus number 1. Then this is kamu punya diagram should look like this for the per unit diagram for this example. Then you can try again for example exercise problem 6.5. So the fault level and the short circuit current of your punya actual value is this value. Okay, so I will share you this slide. You can try it on your own, and if you have any problem, in order to solve the problem, I will be in school if you want any help. So that's it for this lecture. Thank you for listening. Assalamualaikum warahmatullahi taala wabarakatuh.